What is up, guys? So today we are, well, first of all, welcome to another episode of CCT. This one, I think you're going to want to pay attention to a little more. This is something that I've been thinking about since, I don't know, as soon as, no, not as soon as I learned about the binary system, but let's say maybe about 2 years ago or something. And it was when they told me, and by they I mean all my professors, all my teachers, and all of the internet, told me how to convert. Let's just pick a random binary number. Like let's pick, or no, sorry, just a decimal number for now. Let's just pick, I don't know, 103. How to convert this decimal number into a why does this look like a... Alright, there we go. Sorry, I just like the little button better. Okay, the little circle. Into a binary number. And they proposed a very, sugary way, a very sweet way to do this. And I hate sugar ways to do stuff. So this is how they showed me how to convert this decimal number into a binary number. What they said is you take the remainder and you put it here. Okay, so the remainder, oh sorry, after you do mod 2, what's mod 2? So you have like a mod 2 section, and yeah, so then that's that, and then you divide by 2, so then you get about 51, and it's truncated too. And then you see, does this have mod 2? Yep, that's 1. Then you go, that turns to 25. That's a 1. Again, 25 is odd. So then that turns to 12. And that is even, so it gets a 0. That goes to 6. 6 is even. And then we get 3. 3 is odd. And then a 1. And then is, oh no, yeah, a 1. And then 0, 0. Okay. And then the binary number now is, this is going from left to right. It is 1. I'll write it up here actually. 1 1 0 0 1 1 1. Wow, that is enlightening. Who would have thought that it's that simple? That's how you convert decimal to binary. Now, there might be some things. Well, okay, let me first say this. About 95% of people who know how to convert from decimal to binary will use this and be happy. And those 95% of people don't give a shit of why it works. Okay? This is just like multiplication, okay? Does anybody, how many people really care how to multiply, why this works? Why you go 3 times 2 is 6, that's 15. Then you put a 0 here. Wow, that's kind of magical. Why would you put a 0 there? I don't care. It just works. Then you add these together. Great. 6, 7, 6. Beautiful. That is what syntactic sugar is. Sorry, mathematical sugar. There's also syntactic sugar, but this is mathematical sugar. And I hate mathematical sugar. This is so stupid. Okay? I see so many YouTube videos or so many Facebook videos that are like kind of shitting on Common Core. Shitting, and this is not Common Core, this is regular. Teachers love this. There's so many people in this world that love this. They just like to get this done. This is stupid. Just let me know a quick way to multiply numbers. And it's like, great. You have a fucking calculator on your phone, okay? If you need to know how to multiply numbers, just put it on your calculator. That's not the point of math, okay? Maybe that was more useful back when we didn't have calculators in our pockets, okay? But now that we do, it's time to learn a more important thing of why the fuck this works. Okay, and so that's what Common Core is doing. Why this is relevant to talk about is because that is exactly what this is doing. This is bullshit. This is syntactic, mathematical sugar, okay? Okay, so let me just explain, first of all, further why this is such bullshit. Okay, so 103, what we do is we mod to it, that's a 1, and then we divide it by 2. So in my mind, what I'm thinking is this 1 is the least significant 1. And I'm thinking, how does that 1 impact this 103 so much, such that it can divide it by 2? Like, this is the most significant bit. This represents that bit, so b times 2 to the 0, plus whatever is here. So how the fuck does that, how the fuck does this 1 here make you able to divide it by 2 and continue this, you know? Like, that did not make sense to me, and I had to think about this a while to, sorry, I have a stuffy nose now. Yeah, I had to think about this a while to finally understand this. But it just makes no sense. This is the least significant bit. It only counts towards 1 or 0 towards your final number. Yet, after we find this bit, we're able to divide by 2. Okay, now to understanding this. I should have like different sections, because this, like, I kind of thought about this video a lot more than my other videos, even though it might not seem like it. I mean, I did like write down notes of what I'm gonna do, but you know. Okay, so now in order to understand why this bullshit works, you must understand why other bullshit. No, I'm just kidding. Okay, we gotta understand this. Let's take the number 103 again. That's gonna be the go-to number. Let's say you get this number as an int, and you are asked to return it as a string without using the string to int function, you know, the STL function. How would you do it? I want you to pause this video and try to figure it out. Okay, so now that you're back, the way to do this is to what you do is you do the number 1, I'll write it as x. You go like x mod 10, and then that result goes to the string. And then so actually I'll just write it. So while x is greater than 0, x mod 10, x divide equals 10. And then you are adding this digit to your solution, the digit that you modded. So when you mod 103, you get the first digit when you mod it by 10. Right, that's how you get the first digit. You just mod it by 10. And then, so now we have a string. So I'll write this string here. We have it looking like this, and we just got the 3. Now we divide it by 10, and that is essentially cutting off this 3. Am I right? Okay. So now we do the same process again. We do mod 10 to this, and it's again gonna find us that digit, and that's a 0, so we put it in there. Then we divide equal 10, that crosses that out, and we get the 1 here. So you might already be seeing some similarities, okay? I will make this crystal clear by the end of the video. So just bear with me if you want to understand how this works. I want to write this out again. I want to make this clear. The decimal system works like this. It's that number times 10 to the 0, that number times 10 to the first, that number times 10 to the second. And it's a sum of all of these. So let's just say D for digit. Or decimal digit, sorry. Okay. So one observation to make in this is that it is very easy to get the least significant digit when you have a number. Would you all agree with that? And it's very hard. Well, it's not very hard. It's a lot harder to get any of the other digits, right? Like, how are you going to get this digit if I gave you 103? How can you get the middle digit? Can you tell me? Like, if I say, well, I guess you can get the middle digit by dividing by... No, wait, no, you'd have to do 2 steps. You would have to do 2 steps. Right? Can you get any other digit besides the last digit without doing more than 2 steps, right? How would you get the 10th place digit? Well, what you would do is you could chop off everything before by dividing by dividing... Wait, sorry, you could... Yeah, divide by 10 and you cross this one out. Yeah, you could divide by 10 to cross this out. And then you can mod by 10 to get this remaining digit. But you see, you did 2 steps. And like the same goes for any like log number, 1, 8, 9, 3, 7, 2. To get like this digit, what you could do is you could divide by 1,000, and that'll cross all these out. So then you're left with like, so then you're left with 189 if you divide by 1,000, and then you could mod 10 to get this. But that was 2 steps, and more than that, the way that you got the 9 was basically crossing out everything before it, and then modding it by 10. Modding it by 10. That's a key concept to understand. That's the same thing here. Getting the last digit is easy. You just mod it by 10. And we're seeing it occur here, and we're also seeing it occur here. This is an interesting observation, and you should think about this. You should think about this. I like to pace. Think about this observation. The last number is easy to get. And to get any number in between those, you chop them off by dividing by something, and then you mod 10 to get that last digit. Okay, one more thing about why mod 10 would work to get the last digit. So basically, if you're in the decimal system, this is like a more mathy way of why mod 10 gets the last digit. If you're in the decimal system and your numbers look like this, I'd like to represent them like this instead of like how about I represent them? Let's do a compromise. Whoops. Let me represent them like this. 1 times 10 squared plus 0 times 10 to the first plus 3 times 10 to the 0. I'm actually going to represent not write that because that's just 1, okay? So when you mod 10, any part of this, I'm going to call this sum. I'm going to represent this number as, call it a sum. Any part of this sum that is divisible by 10 turns to 0. That's modulus. Modulus will do that. That's a mathy property. I mean, you probably know that, but that's just written out more mathily. Yes, mathily is a word. So any part of the sum that is divisible by 10 is going to turn to 0. That is why this 3, again, that is why this last number is so easy to get, okay? Okay, now let's move on to binary. 103. 103. Okay. I want to get this number again. So it's 1100111. Okay, this is 103. Okay. So, let's make some more observations. This is a lot of observations, a lot of things you need to understand. When you have a function that takes in an int x, you think of it as a decimal number. It in no way is automatically, a decimal is just a way to represent a number. You gotta get that in your head before I start to describe this. A decimal, 103, written out like this, is just one way of writing this number. A number is just a number, okay? What you write, it's just like saying a car, or like the thing you write to describe, like writing to describe something in one language. Like if you write a sentence in many languages, it could mean the same thing, but it's just written in a different way. But they are all the same thing inherently. But it's kind of weird to think about that, because you could have like somebody says, my name is Josh, and then in French you could say je m'appelle Josh, and then so on and so forth for many different languages. So there's many ways to write the same sentence that means the same thing. That's the same thing here. This is like a binary system is no, or a decimal system is no more better or more of what the number is than the binary system. These are the same, just in different languages, okay? Okay, so how does binary system look? I'm going to write this out more clearly. 0, 1, 1, 1. This is times 2 to the 0. Actually, is this how I want to write this out? Yeah. 1 times 2 to the first, 2 to the second, 2 to the third, 2 to the fourth, 2 to the fifth. Okay? Okay. So, the question is, if we have a number, how could I now represent this as a string in the binary language, okay? How could I do that? So I still get the int. Okay. Okay. So, one thing I could do, I am going to write this out in decimal here. So that, because it's just more, we know what this is. Like, it's more human to talk in decimal. So we have 103, and like exactly the same as the decimal system, getting the first digit in a binary number is easy. Remember, over here, we did the first digit in the decimal system is very easy. All we did was mod 10 it. How could we do that? Well, all of these are multiples of 10 except for this one. So all of those turn to 0 except for that one. Very similar thing here too. If we can mod 10 it to this number, remember 103 does equal this. 103 equals this. There's no two ways about that. If we mod it by 2, by the way, this is like pluses. I don't know if I want to represent it this way. Okay, I would rather represent it like this. Just bear with me. 1 times 2 to the 5th plus 1 times 2 to the 4th plus 0 times 2 to the 3rd plus 1 times 2 to the 2nd plus 1 times 2 to the 1st plus 1 times 2 to the 0. All right, and I'm not going to represent that because that's just 1. Right. So if I want this first digit here, if I want what's here, this 1 here, because I want the first part of my string, right? If I mod this by 2, all of these parts can turn to 0. And guess what I'm left with? Bingo was his name, though. I get that 1. I get that 1 which I was searching for. Okay? So, interesting. Interesting. I get that 1. Okay, great. So now I'll write my string up here. I got the 1. Excellent. Now I gotta get the rest of this number. So how should I continue? Well, one thing I could do is, let me erase this. No, not undo. Ugh, where's my eraser? There it is. Let's go back up here. Okay. 2, 0, and that was 1. Okay. To get the next number, we just got this number, which is great. Now, how do I get the next number? So remember, I said before that the only number that's easy to get is the last number. And if you want a middle number, you need to cross out everything before by dividing, and then mod, and then this like 9 becomes the last number, so then you can mod 10 to get it. Okay, interesting. So here, what I could do is I could get rid of this 2 here. I could get rid of this, I could get rid of this first bit. And how could I do that, actually? How could I just get rid of this first bit? Let's go back to this 103. Representing it now in decimal system only because us as people have been brought up with a decimal system. So to just take off this 1, if I take off this 1, that's first of all, it is what, you know what it's doing? It's subtracting 1 by first turning it to 0, and then it's dividing everything by 2 because everything here is shifted to the left. Let's think about that one more time. So we have so now instead of 1 0 1 1 1, we are going to 1 1 1 1 0. Oh wait, are there 2 zeros? Yeah, my bad. Okay, you get the point. You get the point. There was apparently an extra 0 there that I fucked up on. Okay, to go from here, I'm then going to here. Okay, what is this doing? This is 103. When you take off a number here, that is like dividing by 2, but a little more than that, it's also truncating your answer, right? 103 divided by 2 is 52.5, okay? I can't represent that decimal right now. That's not what I'm here for, okay? I am taking this 1 off. What that means is I am subtracting 1 first and foremost. So then that becomes 1 1 0 0 1 1 0. And then I'm taking off the 0, which means, in other words, shifting everything once to the right. Wow, did I actually fucking say left up here? I can't believe I fucking did that. Okay, I still fuck up my left and rights apparently. Great. I meant to the right. Anyway, and that is how you get that, okay? So now 51 is representing this here. We have managed to get rid of this. We have managed to cut off that part. Now, how do we get this digit now? Well, what we could do is the same. Remember, it's now the end digit. End digits are easy to get. We made it the end digit too. That wasn't by coincidence, okay? So we mod it by 2. And why does this work? Let's write it out. We have 1 1 0 0 1, 1. Wow, that's not what I meant to. I need to draw this out. So 2. Okay. Just to throw back, this is supposed to go 2 to the 6. So because there was an extra 0 there and I fucked that up. So this one's actually 2 to the 5th. So don't get confused like, oh, how is it still 2 to the 5th? No, this was supposed to be 2 to the 6th. Let me just write this. Suppose 6, and then like all of that change. Okay, so now we're at 2 to the 5th times 1 plus 2 to the 4th, 1 plus 2 to the 3rd times 0. There is supposed to be another 0 there. Plus 2 to the 2nd times 0 plus 2 to the 1st times 1 plus 2 to the 0. You know, I should have really drawn the ones before. Okay. So this is our new number, which is 51. And then to get this digit here, when you mod 2, all of these turn to 0 because that's just what modulus does. And then we're left with the n number. The n number is easy to get because you could use modulus in this trick. That's why we shifted everything over. Okay? Right shifting like this is dividing by 2 and truncating. Okay, so we got the 1 here, so that means we could put a 1 over here. And then the same process can continue. We could divide by 2 and get 25, and then we have 1, 1, 0, 0, 1. Right? Now we've managed to cut off that one, and we're left with this. Now to get this digit here, we just mod by 2, right? And then with that same trick applies. Great. We get 1, and then we get 0, and then we'll get 0 again, then 1, then 1. Okay. One thing I want to look at is, hey, wait a second. Back up here. That is kind of what this math sugar was doing. It modded by 2. And what that was trying to say is if you mod by 2, you are able to cross out all of these, right? Those all become 0, and then you are left with this. That's 1. Great. Next step, divide by 2. Well, not exactly divide by 2. Divide by 2 and truncate. So that's equivalent to saying just cross this out. That's how you cross that number out. And when I say cross out, I don't mean leave a 0 there. I mean subtracting 1, then shifting everything to the right so that you are left with 1, 1, 0, 0, 1, 1, which is what this 51 is. Great, and we did that so that we could look at this next number and then do mod 2 here to get that. Okay? And then the same pattern continues. Divide by 2 so that you can cross out that part and get that. Recap time. Okay, so this whole conversion is based off of the fact that it is not easy to get the middle digit. In order to get the middle digit, you have to cross out the things at the beginning and then mod it by the decimal system. Okay? The observation though, the other observation is that it is easy to get this last digit. And in order to get these middle digits, you basically use that property and then you take those off before it. Okay. So final thoughts. Any system, you can do this with any system. So hexadecimal system is the same thing that just goes up to 16. So if you have like A3, 9, that's 9 times 16 to the 0 plus 3, 16 to the first plus 11, 10, sorry, 16 to the second. Okay? And so the trick is to get this 9, you mod it by 16, so that crosses all those out. Yeah, and then you get this part. Then to cross this 9 out, you could divide by 16, and dividing by 16 will cross this 9 out there. One small thing before we're done, I just want to recap on the idea that this is why my original confusion, and maybe your original confusion too, this 1 represents the first one, and which is the least significant bit, and then you divide by 2 to get to 51. Like why that one, that the least significant one was able to divide it by 2 and then like continue it this way, and that's because you're literally taking off the last bit, or you're literally shifting everything to the right. That's why getting this 1 has such a dramatic impact on finding the next number. Okay, I'm not sure if that last part made sense, but hopefully this video gives you more intuition or how to convert from decimal to binary. I've certainly seen a lot of questions that use this property, and it's good to actually understand this, like interview questions. And I think I might do a video on one of those interview questions that I've seen before. Okay, well, hopefully you've understood what I've said. If not, go back through the video. And thanks for watching CCT. I'll see you guys next time.